Okay, this is our first question in our proof packets, and it's going to be working with using parallel lines and proofs. And I thought it would just be really helpful to see some examples of proofs in which we used parallel lines to get what we need to prove something else. So, for example, this first given, AIE and LIC, is telling me that I have these two straight lines. And remember, when you have two intersecting straight lines, they give you vertical angles. So this given is going to lead me to one more statement and reason, which eventually will lead me to angles. So let's mark that down first. So statement number one is going to be that AIE is a straight line and LIC is a straight line, and that is given. Now I know that my second statement is going to be angle AIL is congruent to angle EIC. Again, remember, the letter in the middle is always the angle at the vertex. So in both cases, that would be I. And the reason for that is intersecting lines form congruent vertical angles. Okay, so this is really important, guys, because that first given led me to an angle. And I know some of us like to write all of our givens at once, but I really do feel like it's more helpful if we just use them one by one. I'm even going to go ahead and skip my second given and go right down to this one. The reason why I'm skipping my second given is because it gives me a lot of possibilities of what my next statement could be, and I just want something really direct before I worry about what I need. And I'll point out what I mean by that in a minute. So that third given is that AL is congruent to CE. And that is what I like to call a one and done given. So I don't have plus anything for that. That is just right away giving me a side. Okay, so that's giving me a side. So I don't have plus anything, that's one and done, right? Now, I'm going to go to this given here. All right, this given is telling me that AL is parallel to CE. Okay, given. Now, we're going to see how that's helpful. So keep in mind, if you want to mark parallel lines, it's little arrows, right? But I want to think about what I actually want here. If I'm taking a look at what I want to prove, which is that these two triangles are congruent, I know that I have a side and an angle thus far, but I don't have anything else, okay? Parallel lines can give me angles, and it can give me a lot of different types of angles. It can give me alternate interior, it can give me corresponding. So which angles you use are really up to you or up to the diagram. So in this case, if these are my parallel lines, the angles that I see are connected by a transversal. So you should always really try for the Z. So in this case, this Z would give me this angle here and this angle here. Those are alternate interior angles. Now, I just want to point out, you could have drawn your Z the other way, and it would have given you this angle here and this angle here. Those are also alternate interior angles. So you actually do have a lot of different options on how you want to use this given of parallel lines. So I'm going to choose to see my Z this way, right? And I'm going to choose that this angle here and this angle here are congruent, and we're going to use alternate interior angles for those. So let's start with statement number, let's see, what are we up to now? 5. So after parallel lines, there is going to be one more, right? It's just a matter of which angles are helpful to me. So again, we're using that middle letter. So this is going to be LAI. So A is in the middle, so that's why we're using that there. And angle CEI. And those are congruent. And the reason why they're congruent is because when parallel lines are cut by a transversal, they're alternate interior angles are congruent. Sorry, I know I'm a slow writer. All right, so alternate interior angles are congruent. And just a small reminder that this is the only thing that changes, the angle relationship and just the relationship that they have, right? So those angles being congruent. The rest is just the template that we follow every time. So now I can go ahead and I can say my final statement that triangle ALI is congruent to triangle ECI. And the reason is, let's take a look, right? So I'm just going to zoom in here at this one triangle. I have, let me see if I can get a more vibrant pen. So I have this angle, then I have this angle, then I have this side. So it's angle, angle, side in this case. So down here, angle, angle, side is congruent to angle, angle, side. So that is helping me. That is using parallel lines to get what I need to prove those two triangles congruent. I'm going to tell you 9 out of 10 times it's either alternate interior angles or corresponding angles, but that doesn't mean it can't be something else. Those are just the most frequently used. So let's try example number 2. Example number 2, again, this first given of parallel lines is like something where it's all right, well, what do I need here, right? So I'm going to leave that until the end. I'm going to do my others. I am going to take note in that what it's asking me to prove is 2 angles. So that means I'm going to end up using CPCTC. So I have to prove those triangles are congruent first. So if I go to this first given that B is the midpoint of AD, I see B is the midpoint, and a midpoint gives me 2 congruent halves. So I have +1 here, and then it will give me those line segments. So let's go ahead and mark that in. Statement number 1, I'm going to say B is the midpoint of AD, and that's given. And that, what does that give me? A midpoint gives me that AB is now congruent to BD. And why is that? Because a midpoint divides a line segment into 2 congruent halves. Okay, so that already gave me a side in those triangles, which is great. So now let's take a look at our next given. Our next given looks to be a one and done. It's saying that DE is congruent to BC. So let's go ahead and just mark that down. It doesn't look like there's anything more I need to do. I'm just going to move this down so it aligns nicely. So it's telling me that DE is congruent to BC. And this is given. So that is a one and done. That gave me that side. And now you'll notice, right, when it talks about these parallel lines, let me just get a highlighter here. When it talks about these parallel lines, DE and BC, these are the lines. And you'll notice I usually do try to extend them because it's a little bit easier to kind of see the way things work in them. So these parallel lines, now I also want to note that this is a transversal. It's crossing both of them, right? So if I want to think about an angle that's up against those parallel lines and up against that transversal and in both triangles, it really is going to be this angle here and this angle here, okay? Now note, those 2 angles are in the same position. So those are corresponding angles. Okay, so now I can get those angles using corresponding angles, which I'm allowed to use because I know the lines are parallel. So that means statement number 4 is that DE is parallel to BC. That is given. And now I can say, so I'm not going to say angle B. I could say angle D if I wanted to because there's no other angle there, but I can't say angle B. So let's use the 3 letters just to be overly cautious. I'm going to say angle EDB is congruent to angle CBA. And we're going to do exactly what we did before. We're just going to change out the relationship. So when parallel lines are cut by a transversal, their corresponding angles are congruent. So again, it's the same kind of scaffold reason as last time. It's just instead of alternate interior angles, we're using corresponding, and they're congruent again because that's their relationship. So now I have enough. If I zoom into this triangle, I clearly have side angle side. So I can prove those two triangles are congruent. Now keep in mind, that's not what they asked me to do, but that's what I need to do first. So now I can say that triangle DBE is congruent to triangle BAC because of side angle side being congruent to side angle side. And now I can clearly say that angle C is congruent to angle E because corresponding parts of congruent triangles are congruent. And if you want to write CPCTC there, you can. This is your CPCTC. Just keep in mind, if you mess up those letters or if they're in the wrong order, you do not get full credit. So again, I used all of my givens, I got my triangles, and now I know those pieces are congruent using CPCTC. And this statement, this given, really helped me to find those angles that I needed. You can use any angle relationship that's relevant when you have parallel lines, but the ones that are most commonly used are going to be alternate interior angles and corresponding angles. I hope this was helpful. You know how to find me.